Hello, everyone. My name is Venki Rao. Thank you for giving me the opportunity to present to you today. My presentation today will focus on Entity Analytics, which is an extremely powerful feature in the IBM SPSS Predictive Analytics platform. On today's agenda, we will start with describing what Entity Analytics is and why it is important for predictive modeling. We will then briefly describe how Entity Analytics works before moving on to a live demo where we will spend the bulk of our time. With that, let's get started. So what exactly is Entity Analytics? It is best described by talking about what it does. Namely, Entity Analytics automatically detects when multiple entities are the same despite having been described differently. So let's take a look at the example on this slide. Is this one person or two people? If you look at their names, they're slightly different. Bill Smith and William R. Smith. The addresses are slightly different. One has a social security number and the other does not, but they do seem to share the same date of birth. It is crucial for us to be able to identify if these persons are the same or not. Because just look at the situation we have here. Bill Smith is an applicant today. He could be applying for a job, a loan, or any number of things. And if you did not have the information that the same person had been previously arrested, you may make a less than ideal decision. So why use Entity Analytics? Because it enhances the accuracy of models by ensuring you're modeling against a complete entity instead of multiple entities. This is very important across industries and across different types of problems. From a fraud standpoint, has this person defaulted previously? If you're a bank and you need to make lending decisions, you want to know the repayment history of the people you're lending to. From a security threat standpoint, you want to know if this person or vehicle was involved in suspicious activity previously. And from a business standpoint, you want to ensure that you can match external customer lists with your current records. So why is this important? Here is a chart taken from the Axiom product briefing earlier this year. Axiom is one of the world's largest database marketing firms. And from the chart, you can see that the more descriptors we have about an entity, the better the performance of our models will be. However, data quality is critical to improve model accuracy. If your input data is poor, so will your output. And analysts routinely face steep challenges as they attempt to integrate diverse data, especially when this data contains natural variability of the Bob versus Robert type, unintentional errors such as getting the format of your date of birth wrong, as well as professionally fabricated lies, such as a fake identity. The fact is that more accurate data simply results in more accurate models. So how does Entity Analytics work? You start with loading your existing customer list into the Entity Analytics repository. Once you do that, you can check new customers against that repository, which then scores those customers in real time to drive the results that you want to see. These results could be something as simple as providing marketing offers to something as serious as detecting fraud in a loan application process. For our demo today, we will take a simple case where we will use Entity Analytics to generate marketing offers in real time for an e-commerce website. The example is a simple one, but I would like you to focus on the concepts which are extremely powerful and are applicable across industries in a variety of use cases. The last thing I would like to add here is that Entity Analytics ships as an out-of-the-box capability with IBM SPSS Modeler Premium, something that no other data mining software provides. With that introduction, we are now ready to dive into the demo. During my demo, I will take on three distinct roles. The first role I will take on is that of a consumer who logs on to an e-commerce website and takes actions based on predictive output. Now, this consumer just sees personalized offers and recommendations come through, but really doesn't know that predictive analytics is driving this in the background. And frankly, this person doesn't care. The next role that I will take on is that of the data miner. And here we'll take a behind-the-scenes look at how Entity Analytics works within SPSS Modeler. The final role that I will take on is that of a business analyst, someone that has a robust knowledge of the business and uses the output of the predictive model and the entity analytics process to drive these personalized recommendations for the consumer. I'm now going to exit PowerPoint and get into my demo environment. What we see here is the e-commerce website of a fictitious pharmacy where customers can log on and buy products online. As with all websites, customers can log into their accounts and find personalized recommendations and offers. At this point, I want us all to think about our own experience with online shopping. Personally, I log into a website, especially if I don't use that website very often, and I forget that I had used the website before, or I forget the email address with which I had signed into that website previously. So what do? I just sign up again. As a result, this website contains multiple profiles for me. What we are going to see is how Entity Analytics resolves these different profiles so that I, as a customer, can get one unified shopping experience that benefits not just me, but as you will see, benefits the retailer as well. So let's start with the customer who is visiting this website. She has forgotten her user ID and has just signed up for a new ID. Let's log in. And as you can see, her name is Kate. And immediately upon logging in, she sees an offer which states that she will get 5% off on all online purchases. Let's take a closer look at this offer. You can see here that Kate's projected probability to respond to this offer is 0.5, with a projected profit for the retailer of $1. So let us understand why this is the case. As soon as Kate logs in, IBM's analytical decision management application looks at her profile, which in this case is new, that is with no history, and decides that based on how much it is going to cost us to make her this offer, as well as her probability to respond positively, this is the most profitable offer we can make to Kate at this point in time. Let us now turn on the Entity Analytics capability on our website. Having done that, let us revisit this transaction that we have just seen. Once again, let's log on as Kate and step into her shoes once more. Once we do that, this time we see that the offers that the website gives us are very different from the offer that we had seen previously. While previously we saw one offer which said 5% off on all online purchases, now we see two offers. The first one being extra 25% off your meds, and the second one being free shipping on all orders in excess of $30. Why did this happen? This is because when Kate logs in, our Entity Analytics engine is able to determine in real time that Kate is an existing customer of ours. And her name here is Katie Amick, and she has an existing account with us with the number 10040. And her retail history with our firm clearly shows that she has a high affinity for meds and treatments, so it makes sense for us to make her this offer. Let us also take a look at two other things here. The first one is her probability to respond positively to this offer. We see that it is 0.61, which is much higher than 0.5 we had seen earlier. So this is a better offer for Kate. But equally importantly, let us take a look at the projected profit for our firm. Where previously we had projected the profit to be $1, we now see that the projected profit from this offer is $3.88. Clearly, with Entity Analytics, this is a win-win situation both for Kate as well as for us. Next, let us take a look at the Entity Analytics details. Here we see the column on the left refers to the login customer, and the column on the right refers to the matching customer in the EA repository. The left column displays the information that Kate provided when she signed up for a new account. The column on the right shows the matching customer in the EA repository, and as you compare these two, you can notice a slight variation in the given name, Kate versus Katie. The same thing with the street address. In one case, Lane is spelled out completely. In another case, it is abbreviated. However, There are several pieces of information in these two records that match. For example, her email address is the same in both cases, as is her gender. Based on this, we know it is our existing customer case, and we can treat her as an individual rather than as a customer segment. This enables us to provide her with customized offers that are beneficial to her as well as to us, as we have just seen. Let us take a look at another example of entity analytics in action. Let's log in as a new customer now. Here we have a customer called Carolyn who logs in and receives two offers in real time. The first one being 20% off on personal care products, and the second one being free shipping on all orders over $50. Let's look under the hood and see why she's getting these offers. You can see that Carolyn's is another case of an existing customer who set up a new account in order to log on to our website. If you look closely, you will see that Caroline's last name that she gave when she set up a new account is Brown, whereas the name in the EA repository is Martinez. You're probably thinking why these profiles have been matched despite having different last names. The reason is that there are other pieces of pertinent information that show us that, in fact, Carolyn Brown and Carolyn Martinez are one and the same person. For example, she has the same email address, the same phone number, the same date of birth, and the same gender. And these fields are sufficient to tell us that these people are the same despite the slight variation in the street address as well as a typo in the city name. So the main point here is that the level of entity analytics resolution is configurable. You can configure it to be aggressive, which is what I have done here, or you can configure it to be conservative. An example of a conservative resolution would be one that is based on pieces of information that are very stable and exclusive. For example, a social security number. I'm now going to exit our website and go into SPSS Modeler to give you a behind-the-scenes look at the entity analytics that is driving the user experience we just saw. So I start with a database of my existing customers. So let's take a look at what our existing customers look like. And we can see here that we have a lot of information about our existing customers, including their given name, street address, and so on. And if I scroll all the way to the right, I see that there's also a lot of historical information about them in terms of cloud scores, affinity scores, and so on. So the first step in the process is to export this data into the Entity Analytics repository. And in order to do that, I first have to specify the type of entity I'm dealing with. In this case, since this is a customer list, I'm going to pick the person entity. But as you can see, I can add any number of different types of entities, including companies, vehicles, etc. The next thing that I do is map each of these fields in my customer list to features in the Entity Analytics repository. And once I complete that, I hit run and I export the data to my Entity Analytics repository. The next stream here shows you what happens when a user logs into our website. I have a database of new customers. Let's first take a look at those new customers to see what information we have about them. So in this list of new customers, we've captured all the information that we need to set them up in our system. But as we scroll to the right, we see that obviously since they're new customers and don't have a retail history with our firm, the cloud scores as well as the affinity scores are 0. So what then happens is that as soon as they sign into the website, the streaming EA node here pushes the new customer information to the Entity Analytics repository to find a potential match. Once a match is found, I can take that ID and look up the matching profile to find the affinity and cloud scores, which will drive the personalized offers in real time. For example, when we run this table node and we take a look at Carolyn Brown, we see that it's now resolved this identity of Carolyn Brown with Carolyn Martinez. And when we scroll to the right, her class scores and affinity scores, which were previously all 0, have now been populated with her historical information. And this is what is happening in the background. I'm now going to exit SPSS Modeler and go into IBM's Analytical Decision Management application and look at the streams that are driving the personalized offers to each of our customers. We are now in IBM's Analytical Decision Management application. This is the stream that's driving these offers that we have been making to our customers when they log on to our website. Here we define two different campaigns, the first one being segment promotion and the other one being the customer retention campaign. Let us take a look at the segment promotion campaign in some detail. In IBM Analytical Decision Management, I have set up simple business rules to say that if a customer has a high affinity towards beauty products, the system should make them a real-time offer on beauty products, and so on. So it's a simple rule. It simply says if the beauty affinity score exceeds 0.4, then make them an offer on beauty discounts. Similarly, if it exceeds 0.4 for personal care affinity, make them a discount in personal care products, and so on. And finally, just because a customer is eligible for an offer does not mean that we should make them that offer, since ultimately we should only make those offers that are profitable to us as a firm. We have a simple prioritization equation in place that helps us determine whether an offer is made or not. And as we can see here, the prioritization equation is pretty simple. It starts off by taking the probability to respond, which is the customer's probability to accept an offer, multiply that by the amount of revenue that our firm is going to make. And only if the product of those two numbers exceeds how much it is going to cost our firm to make them that offer, do we make this offer to that customer. So let's recap what we saw today. We started with an e-commerce website where we showed two scenarios, one with Entity Analytics and one without. We saw that with Entity Analytics, there was a win-win situation. Our customers got better and more personalized and customized offers, and we earned higher profits. We then took a look at Entity Analytics at work inside SPSS Modeler and saw how new customers are scored by the streaming EA node in real time. Finally, we looked at IBM's Analytical Decision Management application, where we saw how the personalized offers for each of our customers are generated. The last thing I would like to say here is that the capabilities you have seen in action are not easily accomplished programmatically, meaning it is not simply a matter of writing pattern matching code and hoping that you achieve the same results. What we have here is an IBM solution that you can configure and is ready for you to deploy into your environment to drive your business product. That brings me to the end of my presentation. Thank you for your time today. If you have any questions or comments, please feel free to reach out to me at raove@us.ibm.com. Thank you.